Hi, I am Syed on Maths Online. Today's topic is unit step function. In the previous video, we have seen the definition of unit step function and we have even solved problems based on unit step function. Today we'll try to discuss about discontinuous functions, how to express them in terms of the unit step function, and we'll also try to find out its Laplace transform. We'll try to see some properties based on this discontinuous function. The first property is if f of t is equals to f1 of t for the value of t less than or equals to a, and f2 of t if t is greater than a, then the function f of t is represented by f1 of t, the first function, plus it's the difference of the second function minus the first function, that is f2 of t minus of f1 of t times of it is u of t minus of a. That's the first property we have. So whenever you have discontinuous function of this form, you have to write down f of t is equals to f1 of t plus the second function minus the first function, f2 of t minus f1 of t into u of t minus of a. That is the first property we have. Now let us move on to the second property. If f of t is equals to, suppose if you have three functions over here, f1 of t where the value of t is less than or equals to a, f2 of t where the value of t lies between a and b, f3 of t if t is greater than b. So in that case, you can write down f of t is equals to the first function f1 of t as it is. Then you have to take the difference of the second function minus the first function, that is f2 of t minus f1 of t into u of t minus of a, this particular interval that you have. So t minus of a plus the next term will be the third function minus the second function, f3 of t minus f2 of t into u of t minus of b, the interval that you have over here, u of t minus of b. So these are the two properties that we have. Now based on these two properties, let us take few examples. Let us start with the first example. Question number 1. Express f of t is equals to, the discontinuous function is t, the interval is 0 less than t less than 3, it is 2 where t is greater than 3. This here to express in terms of unit step function, and find the Laplace transform, So let's take the solution. So if you try to observe, this function f of t is written in the form of the property number 1. So I can apply property number 1 over here. So if you try to consider over here, let us take the first function to be equals to f1 of t. So f1 of t is t itself, f2 of t is 2. And what is the value of a over here? The value of a is equals to 3. So if you try to see the property number 1. So what does this property number 1 says? You can write down the function f of t is equals to the first function f1 of t plus you have to take the difference of the second function minus the first function, f2 of t minus f1 of t into u of t minus of a. Just try to plug in the values of f1 of t. f1 of t is t plus f2 of t is 2 minus f1 of t is t times of, it is u of t minus a value over here is 3. Now let us apply the Laplace transform both the sides. Laplace transform of f of t is equals to Laplace transform of the first function, Laplace transform of the first function t, Laplace transform of 2 minus of t into u of t minus of 3. So let us apply the Laplace transform. Laplace transform of t, just using this basic formula of Laplace transform of t power of n will be n factorial divided by s power of n plus 1. In this case the value of n is equals to 1. So Laplace transform of t will be equals to, it is 1 factorial divided by s power of 1 plus 1. So it is 1 divided by s square. So Laplace transform of t, you get it as 1 by s square. So we need to find out this particular Laplace transform. So I'll keep it as it is over here and try to calculate it separately. So we need to find out this particular value. So I'll just take this as equation number 1. We know that Laplace transform of f of t minus of a into u of t minus of a is equals to, it is e power of minus of as into f bar of s. Since I have already used f of t over here, so if I try to find out its Laplace transform, once again I will be getting f of t. So just to avoid that confusion, I can rewrite this as Laplace transform of, instead of small f, I'll just write it as capital F. Just to avoid the confusion, I can rewrite the formula as capital F of t minus of a into u of t minus of a is equals to, it is e power of minus of as. Here also I will be writing it as capital F bar of s. So now if you try to compare the value of a in this case, so you can try to see over here it's t minus of a. So your value of a in this case is 3. So if you try to plug in this value over here, Laplace transform of f of t minus of 3 into u of t minus of 3 is equals to, it is e power of minus of 3 times of s into f bar of s. So now I need to calculate this f bar of s. So let us try to calculate this f bar of s. So this equation, I'll take it as equation number 2. So now what is this value of f of t minus of 3? F of t minus of 3 will be equals to, so if you go back to equation number 1 over here, the equation number 1, it is f of t minus of a is nothing but 2 minus of t. So this f of t minus of 3 can be taken as, f of t minus of 3 can be written as 2 minus of t. So to get this as f of t, I'll just add 3. So therefore I can rewrite this as t minus of 3 add 3 over here, which will be equals to, it is 2 minus, here also I'll add 3. So t plus 3. So what happens is this minus 3 and plus 3 will cancel out. You'll be getting f of t is equals to, if I try to rewrite this one, it is 2 minus of 3. So 2 minus of 3 will be minus 1. So we'll be getting minus 1 and minus of t. So now let us find out the Laplace transform. So if you try to find out its Laplace transform, so it is Laplace transform of f of t is equals to, if I take negative sign outside, is Laplace transform of 1 minus Laplace transform of t, which will be equals to minus of. Now Laplace transform of a, we know the formula as a by s, that is the first term result. The second term result, Laplace transform of t power of n will be equals to n factorial divided by s power of n plus 1. Just above I have calculated this Laplace transform of t. using the same procedure, 1 factorial is 1 divided by s square will be getting. So which is the Laplace transform of t. So if I try to rewrite this one, this becomes a by s. So a by s in this case, a value is 1, so we'll be getting 1 by s. So we'll be getting 1 by s, and here it is minus 1 by s square. So this represents your capital F bar of s. Because I have taken capital F of t, I will take this as capital F bar of s. You try to plug in back over here in equation number 2. So equation number 2 will imply Laplace transform of f of t minus of 3 into u of t minus of 3 will be equals to, it is e power of minus of 3s into f bar of s is minus 1 by s minus 1 by s square. But again I need to plug in this value back in equation number 1 because I have to calculate the value of Laplace transform of f of t. So I'll try to plug in this value back in equation number 1. So if I plug in back in equation number 1, so equation number 1 will imply, equation number 1 will be equals to, it is Laplace transform of f of t is equals to, I have already obtained the value to be equals to 1 by s square, that is the first term, plus the next term is this particular value itself, which will be e power of minus of 3s into minus 1 by s minus 1 by s square. Or if I take negative sign outside, I can rewrite this as 1 by s square, positive into negative will be negative, e power of minus of 3s into, you get 1 by s plus 1 by s square. You can just group in this 1 by s square and 1 by s square value, which can be written as, I'll just write down this 1 by s square as common. So if I take 1 by s square as common, I'll be getting the value to be 1 from here, and negative sign is there, so it is minus of e power of minus of 3s, and this term 1 by s has to be multiplied by minus e power of minus 3s. So minus e power of minus 3s into 1 by s. So that will be the final solution. Let us move on to the next question. Express f of t is equals to cos of 2t 0 less than t less than pi, and it is equals to 0 for the value of t is greater than pi. So once again, if you try to observe over here, the first function I can take it as f1 of t. So f1 of t will be cos of 2t. The second function f2 of t is 0. And what is the value of a over here? The value of a is pi. So now if I try to rewrite this discontinuous function f of t, the formula that you have is f1 of t plus the second function minus the first function, that is f2 of t minus f1 of t. It is times of u of t minus of a. So just plug in the values of f1 of t. f1 of t is cos 2t plus f2 of t is 0 minus f1 of t is cos 2t. It is times of u of t minus a value is pi. So if you try to rewrite this one, this will be cos of 2t minus cos 2t into u of t minus of pi. So we have expressed in unit step function. Now take the Laplace transform. Laplace transform of f of t is equals to, apply the Laplace transform for the first term as well as for the second term. Right, let us take this as equation number 1. So I need to find out the Laplace transform of the first and the second term individually. So let us find out the first Laplace transform of cos 2t. We know the basic formula of Laplace transform of cos at is s by s square plus a square. So if I try to rewrite over here, it is s by s square plus a, in this case is 2, so 2 square. So you will be getting the value to be s by s square plus 4. So we have got cos 2t Laplace transform, first term. Similarly, I will try to find out the Laplace transform the second term. So we will take this as say equation number 2. So now we will try to find out the Laplace transform of cos 2t into u of t minus of pi. Alright, and we know the formula Laplace transform of f of t minus of a. So I am just taking in capital letter just to avoid the confusion. It is u of t minus of a is equals to, it is e power of minus of s into f bar of s. So in this case, if you try to observe, the value of a is pi. So here your value of a is pi. So if you try to rewrite Laplace transform of f of t minus of pi into u of t minus of pi is equals to e power of minus, a value is pi, so pi times of s into f bar of s. So I need to find out the value of f bar of s. Let us take this as equation number 3. So here we have the value of f of t minus of pi. So if you try to compare, t minus of pi is nothing but cos 2t. So you can write this as cos of 2 times of t. So it is f of, I have to get t over here. So because you are having t minus of pi, you add pi over here, which will be equals to, it is cos of, it is 2 times of, so t will become t plus pi. However, over here this minus pi and plus pi will get cancelled. You will be getting the value to be equals to f of t is equals to, it is cos of, if you try to multiply it, it is 2t plus 2 pi. Now this is in the form of cos of 2 pi plus theta, 360 plus theta. This will be nothing but cos theta itself. Cos 360 plus theta will be cos theta. So using that property over here, I can write cos of 2 pi plus theta will be cos theta itself. So we'll be getting cos 2t itself. So now let us try to find out its Laplace transform. So Laplace transform of f of t will be equals to Laplace transform of cos 2t. And we know Laplace transform of cos 2t will be s by s square plus a value is 2, so 2 square. That is nothing but s by s square plus 2 square will be 4. So I can take this value to be equals to capital F bar of s. I need to plug in this value back in equation number 3. If you plug in this value back in equation number 3, equation 3 implies, you just see above there you have equation number 3. So Laplace transform of f of t minus of pi, I have taken that as cos 2t, into this u of t minus of pi, I'll write it as it is equals to, it is e power of minus pi s as it is, and you have f bar of s over here, that is nothing but s by s square plus 4. So I need to plug in the present equation and this equation number 2 back in equation number 1. Let me take this as equation number 4. So substitute equation 2 and equation number 4 back in equation number 1. So we'll be getting Laplace transform of f of t is equals to, equation number 2 is s by s square plus 4. It is minus of, equation number 4 is e power of minus pi s s by s square plus 4. But if you try to observe over here, s by s square plus 4 is common, so you can take s by s square plus 4 as common outside, so you'll be left out with 1 minus e power of minus of pi s. That's the required solution. Let us move on to the next question. Question number 3. Express f of t is equals to sin t, and the interval is 0 less than t less than or equals to pi by 2. It is cos of t for the value of t is greater than pi by 2 in terms of unit step function and find its Laplace transform. Now try to compare your f1 of t value over here is sin of t, f2 value is cos of t, and the value of a is equals to pi by 2. So if you write down the formula, we have f of t to be equals to f1 of t plus f2 of t minus f1 of t times of u of t minus of a. Just plug in the values. f1 of t is sin of t, f2 of t is cos of t minus f1 of t is sin of t into u of t minus a value is pi by 2. So let us apply the Laplace transform. So Laplace transform of f of t is equals to Laplace transform of sin of t plus Laplace transform of cos t minus sin of t into u of t minus pi by 2. So we need to find out its Laplace transform. So take this as say equation number 1. So we'll find out the Laplace transform of the first term is the Laplace transform of sin of t. We know the basic formula of Laplace transform of sin at. So sin at formula is a by s square plus a square. So if we try to compare, the value of a in this case is 1 because coefficient of t is 1. So you have it is 1 by s square plus 1 square is 1. So you got sin t value. We'll take this as say equation number 2. Further, we need to find out the Laplace transform of cos of t minus sin of t into u of t minus pi by 2. So let us try to find out the Laplace transform of this particular function. So for that, I will take the value of capital F of t minus of a. Alright, in this case the value of a that you have, a value is pi by 2. So t minus pi by 2 will be nothing but cos t minus of sin t. But I need to get f of t value, therefore what I will try to do is, because you are having minus pi by 2, to cancel out the term I will add plus pi by 2. So here also you add plus pi by 2. The sine of t plus pi by 2. So it is minus pi by 2 and plus pi by 2 will cancel out. You will be getting the value as f of t. Now the first term is in the form of cos 90 plus theta. We know it's cos 90 plus theta will be minus sin theta minus sin t. Next you have sin 90 plus theta. Sin 90 plus theta will be cos. So therefore this negative sign will remain as it is. You just get cos of t. So we got f of t to be equals to minus sin t minus cos t. So let us try to find out its Laplace transform. So Laplace transform of f of t will be equals to Laplace transform of sin of t minus Laplace transform of cos of t. So we know the Laplace transform of sin t will be a by s square plus a square. So a value in this case is 1. So it is 1 by s square plus 1. And Laplace transform of cos at will be s by s square plus a square. So therefore it is s by s square plus a value in this case is 1. So we'll be getting s by s square plus 1. So this will be nothing but your f bar of s. So now if you try to use the property, so we have the property to be equals to Laplace transform of f of t minus of a into u of t minus of a is nothing but e power of minus of s into f bar of s. So this is the Laplace transform of f of t minus a value you have taken it as pi by 2. It is u of t minus pi by 2 is equals to e power of a value is pi by 2. So it is minus pi s by 2. Your f bar of s, both are having negative sign there. I can even take that negative sign outside and rewrite that value to be equals to 1 by s square plus 1 plus s by s square plus 1. Because both are having negative, I have taken the negative sign outside. Further you can take the LCM. It is e power of minus pi s by 2. If you are taking the LCM, s square plus 1. So you will be getting 1 plus s, or I can write it as s plus 1. So we have got this particular expression. Let me take this as say equation number 3. So I need to just plug in this equation number 2 as well as equation number 3 back in equation number 1. Just check equation 1, 2 and 3. So what will be your equation number 1? So go back to equation number 1 and check it. This is the value you have. Laplace transform of f of t is equals to. So the first term is being obtained from equation number 2, which is Laplace transform of sin t, and we have got that in equation number 2. So your equation number 2 will be 1 by s square plus 1. So here then further the second term is your equation number 3. Just go back to equation number 1 and check it. So it is minus e power of minus pi s by 2 times of you have s plus 1 by s square plus 1. Now once again if you try to check the denominator is common. So therefore you can take the LCM over here. So if you are taking the LCM as s square plus 1, so you will be left out here in the first term 1. In the second term it is e power of minus pi s by 2 into s plus 1. So that will be the required solution. That's all I have for today. Thank you.